Does anyone remember anything about absolute value? We have gone over it just a little bit because we've gone over the parent function for an absolute value. Give me anything you remember. Yes, Liz?
Absolute value can't be negative because it's different away from 0.
Yes, exactly. When we take the absolute value of a number, what we're doing is we're taking the positive version of that number. Because absolute value is technically asking what is the magnitude of a number? How far is it away from 0? And distance can never be negative. So whenever we take the absolute value of a negative number, it becomes positive. What else do we know about absolute value? Yes, on the graph, it looks kind of like a V. It's a V shape on a graph. And we're going to graph it in a second. Does anyone remember what the equation looks like? Exactly. F of x equals absolute value of x. Now, when I say absolute value, it's those two vertical lines with whatever we're taking the absolute value of between them. So the parent function for absolute value is f of x equals the absolute value of x. Vertical line, x, vertical line. And this is our parent function. What makes it the parent function? It hasn't been what? Parent functions have not been, yes, has not been transformed. Whoops. So let's go ahead and try to graph it. Now, we're going to try to graph this parent function without using our calculators. Does anyone know, when we don't know what a graph looks like and we don't have a calculator, what's our go-to move? How do we know where to put points on a graph? What do we do? What? No, for any line, for any graph. We're being asked to graph it. We don't have our calculator. We don't know what it looks like. What should you do? If I asked you guys to graph this right now, what would you do? Okay, because you remember the parent function starts at 0, 0. Good. How would you get the next point? What was that? Yes, you do actually on absolute value as well. But no, I'm looking for a specific technique. Anytime you're given any equation, say I gave you 2x squared plus 3x minus 4. Maybe you guys weren't taught this. Whenever you don't know how to graph something, you should immediately insert x values into the equation and figure out what the y equals at that x value. In other words, you're finding points by plugging in values to your equation, creating a little table as you go. And that's what we're going to do. Now, it doesn't matter what x value we start with. We can start with anything we want. I could start with 100 if I felt like it. But I'm going to start with 0. I'm going to put 0 into my equation, f of x equals the absolute value of x. So when I put in 0 for x, what do I output? What do I get? Let me show you guys. So I kind of get the feeling that you weren't taught this ever. Okay, interesting. So if I'm putting in 0, what is the absolute value of 0? 0. So what is our y value? What is our f of x value? 0. When x is 0, our y value is 0. Our f of x value is 0. F of x is the same thing as y on a graph. So I'm going to plot the point 0, 0. Now again, I can choose any x value, but I'm just going to, because math is nice and orderly, I'm just going to go in order and try to plug in 1 now. When I plug in 1, what is the absolute value of 1? 1. So when I have an x value of 1, my y value is 1. When I have, let's do one more going in the positive direction. When I plug in 2, what is the absolute value of 2? 2. Oh, I put the 2 in the wrong column. Sorry, it's 2, 2. So I think that's enough in that direction. That's enough for me to see, okay, going to the right, I am just going up 1 over 1, up 1 over 1, up 1 over 1 all the time, infinitely. This line keeps on going on forever, upwards and to the right. What number do you think I should plug in next? Sure. Okay, let's do it. When I plug in -4, whoops. What is the absolute value of -4? A positive 4. So when I input -4, I output a positive 4. I get a y value of positive 4. Give me one other number. Just one more. Just to make sure. -2, sure. When I plug in -2, what do I get? 2. So I can see that this line is going upwards and to the left as well, infinitely forever, forming this symmetrical V shape. This is our parent function. Anytime you guys don't have a calculator and are confused about graphing, you should do a little table where you're plugging in x values and figuring out what y equals. Any questions on how we graphed the absolute value parent function? Notice it hasn't been stretched or compressed. It hasn't been translated. It hasn't been reflected. It is normal. It is as normal as it can get. I know it hasn't been stretched or compressed because from my vertex to my next perfect point is just up 1 over 1. It's always up 1 over 1 if it hasn't been stretched or compressed. So let's talk about our domain and range. We just did this. We just did domain and range, what, the day before our test? No, 2 days before our test. So let's do interval notation first. Interval notation, what does that look like in general? What does it have? Parentheses, and what else could it have? Square brackets. Good, exactly. Now we ask ourselves, we always go least to greatest. Always ask yourselves, what's the least value and then what's the greatest value? Domain, is that our x or y values? That's x. So what is our lowest x value? X value. Now is it a positive infinity or a negative infinity? if I'm going to the left along my x-axis, I'm approaching negative infinity. My lowest x value is a negative infinity. I'd have to say this is the most missed thing on your guys' test, is you forgot that there is such a thing as a negative infinity, and you just put an infinity symbol. Going to the left brings you closer to negative infinity. Going down brings you closer to negative infinity. Going to the right brings you closer to infinity, and going up brings you closer to infinity. And then what always goes next to infinity symbols? A parentheses. Good, because we can never equal infinity. Then what's our max x value? Positive infinity. And what goes next to that infinity? Parentheses, because we can never be infinity. Guess what, guys? All absolute value, all of them, no matter how it's been transformed, will always have a domain of all real numbers. It will always have a domain from negative infinity to infinity. And you can even write that if you want. All absolute value. Have a domain of all real numbers. Now the range is different. What's our lowest y value? 0. Do I actually have a y value of 0? Is that included on this line? Yes, it is. So what do I put next to the 0? A bracket, a square bracket. So I have square bracket 0, comma, and then what is our max y value? Positive infinity. It keeps on going upwards forever in both the left and right directions. And what goes next to that infinity? Parenthesis. Okay. So now let's do the set notation. How do you guys remember what set notation looks like? Set is always with the squiggly. Good. Set squiggly, set squiggly, set squiggly. Set squiggly bracket. So our domain is going to start off with what? With a squiggly bracket. Good. And domain is always talking about x or y values. So I put an x after the squiggly. Now if our domain is negative infinity to infinity, what's another way to say that? All real numbers. So how do I write this in set notation? With all real numbers, it's the only time you don't need that such that line. Yes. Epsilon, right, is an element of, and then what? All real numbers. That capital R with a double stem looking thing. And then a squiggly bracket. And then our range starts the same way, squiggly bracket, but what am I writing next now? Y. Good. And now, because it's not all real numbers, we actually have a restriction. It's called, what do I put after the Y? A such that, a vertical line. What's our inequality? Where is Y? All our Y values are greater than or equal to 0. Y is everything bigger than or equal to 0. And that's our set notation. Any questions on domain or range? All right. Now just really quick, some attributes. All of these are actually called attributes of the absolute value graph. Where is our vertex for this parent function? 0, 0. Where's our x-intercept? At what point gives us the x-intercept? 0, 0. What point gives us the y-intercept? 0, 0. Now here is a concept that I am always shocked that students don't quite understand this. So I'm going to slow down and take my time explaining this. We need to know whether or not each one of these graphs has what is called a minimum or a maximum. Now when I say minimum or maximum, what I mean is, do we have a point that is lower than all of the other points on this graph? Or do we have a point that is higher than all of the other points on this graph? When I look at this graph, do I have a low point or do I have a high point? So when I say on this graph, I'm just talking about my absolute value line, right? So if I'm following this, just looking at this line, does it come to a peak or does it go to a valley? What's that, Eli? It's like a lowest point. It goes to a valley, giving us the lowest point of 0, 0. This graph has what is called a minimum. This is a minimum point. It's the lowest point for our graph. Right there at 0, 0. That's a minimum point. If we instead, and don't draw this on your graph, but I just want to show you, if we had an absolute value that gave us what looks like a mountain, do you think we have a lowest point or a highest point? Highest point. Whenever it looks like we have a peak of a mountain, that is a maximum, the highest point. So a minimum gives us a low point. You can think of a valley. Maximum gives us a high point. You can think of a mountain. All right. And then lastly, what's our axis of symmetry here? You guys did this a lot in geometry, I think. Or did it a little bit, at least. What is an axis of symmetry? Nobody knows what an axis of symmetry is. Oh, I'm going to be calling up your geometry teachers. Okay, look. An axis of symmetry is a line on the graph where you can fold the graph and have everything line up. It'd be like a mirror image. It'd be perfect. Where could we fold this graph and have one side of the graph perfectly lie on top of the other side of the graph? Oh, along the y-axis is our axis of symmetry exactly here. So, Ugh. That's our axis of symmetry. It's along the y-axis. Now, what is the equation for that line? Oh, it's frozen. So what is the equation for that line? As you're thinking about it, I'm going to write down just what an axis of symmetry is, how we remember what an axis of symmetry is. I remember it by saying in my head where you can fold the graph and have one side lie perfectly on top of the other. It's kind of like a mirror image. So when we're trying to find the equation for the axis of symmetry, I always ask myself, what axis are we passing through briefly? What axis do we pass through for this line that we have? You pass through the x-axis at what value of x? 0. The equation for this axis of symmetry is x equals 0. So if we had an axis of symmetry along the x-axis instead, what do you think the equation for that would have been? Kaylee, if we had an axis of symmetry that is the x-axis, what do you think the equation for that would have been instead? So if we had it here, what's the equation for that line? What axis is it passing through briefly? The y. So this is a y equals line. Now, what y value is it passing through? 0. The equation for that line is y equals 0. What about, let's do that one. What's the equation for that line, Vea? Can you see it? What's up? So it's this line passing through 6 on the y-axis. What do you think the equation for that would be? Exactly. Is that what you said? I'm sorry. I couldn't understand what you said. I was like, I don't know. I'll just repeat the question. Okay, what about this was the last one we'll do. Oh, it's not showing up. Right there. What is the equation for that line? Man, all these people not here. Jose. Ask yourself, what axis is it passing through? Through the which axis? It's passing through the x-axis, so it's going to be x equals. And at what value is it passing through the x-axis? 7. So the equation for that line is x equals 7. You guys should have drilled and killed this in geometry. Did you not? Okay. All right, so it's something we'll need to practice. Good to know. This will probably be our warm-up for next class. Now, everybody needs to get a calculator. All right, guys, so we're taking out our calculator. And first thing we're going to do is we're going to practice putting absolute values into our calculator. Now, if we want to see what this thing looks like, if we want to see what it looks like on a graph, where are we going to input the equation? Into y equals. Good. So you're going to go to y equals. And you're going to press math. And you're going to go over, you're going to press the over arrow key to NUM. That stands for number. And then that very first number one, that ABS, ABS stands for absolute value. You press enter. And you will get the absolute value symbols. So then we're inputting X. The X button is right next to the alpha. And we're first going to try on our first y equals just inputting the parent function, the absolute value of X. And if I wanted to see what this looked like, where would I go? To the graph. I'd press graph, which is that upper right-hand button. And this is the parent function that we've already practiced graphing. Great. But now, I want to look to see what other transformed absolute value graphs look like. So what I'm going to do is I'm going to plug in this next equation, absolute value of X plus 2. So you're going to, again, press math, number, ABS, we're going to put X, but then we need to get outside of the absolute value. So you're going to press the over arrow key, plus 2. So, based on this graph, where has our new function been transformed? It's been translated up to. Now, because we have already learned about transformations, I don't really need you to write out the full words anymore. As long as I know what you're talking about, I'm going to call it good. So if you just put trans and then up to, that's good enough for me. Also, when we're doing vertical or horizontal, if you just put V or H, that's good for me too. Now what I want you to do is I want you guys to practice using your calculators and seeing what each one of these graphs look like in part A, 1 through 4. And I want you to write down the transformations and fill out A and B as well. I'll give you about 5 minutes to do this.